So today we are working on TensorFlow Playground just to get an idea of the neural network. So we will start with the just first of all we will define the basic term. So what is the epoch? Epoch is basically a number of times the neural network has scanned all of your data. It is like how much time, for how much time, or for how much instances has your data been read. Learning rate is basically the rate of learning of the neural network. We cannot shift the weight too high or it would overfit the model, or we cannot make our learning rate too low that the model is underfitted. So it should be a good balance between becoming overfitted and underfitted. So we will have to adjust learning rate. If the learning rate is too much, the model might miss some important uh, might the model might not perform on unseen data. And if while also if the learning rate is lesser, what will happen is, if we give a lesser learning rate, what will happen is the model will actually miss some key aspects from data and will provide inaccurate results. So it is penalizable on both the cases. And activation function, these are the simple mathematical functions, the ReLU, 10x, sigmoid, linear, and all of these functions basically are the backbone of neural networks. Regularization and regularization rate, and what are these is these are the hyperparameters just to penalize the model if the model is getting overfitted and underfitted. And from here we define the problem type, that might be classification or regression. We can choose between the two problems, so we'll go with classification. And then comes which dataset do you want to use. So from simpler datasets to complex datasets, all of the datasets are available. So we will start with simpler and then we will work on to the complex one. Then comes ratio of training data to test data. So what is training data and what is test data? Training data is the data that you provide or feed to the model for training, and test data is the data with which the model compares its results with. And we can also define the noise. Also we can define the batch size. Batch size is like how much of the number of how much data you want to give inside of input. Like if the data if the if we have 100 rows in our training data, so if we select the batch size to 10, this means that 10 rows will be given in one batch to the neural network. So let's start with the basics. So this is a hidden layer, and x1 x2 and all of this is input layers, and these are hidden layers, and an output is will be shown here. So let's start with basics with one hidden layer with a simple with a very simple problem. So let's disconnect all of these and let's reduce the number of neurons. So let's go with one neuron and one input, and let's run it. So this was a pretty basic problem, and with one neuron and one hidden layer, it has basically separated all of the blue dots from the orange dots with a convergence line. But as you can see, the neural network was pretty simple, so it did separate the two, but a few of the points are actually overlapping, meaning that some of the data that the neural network is showing in output is inaccurate. So what we will do is we will increase one neuron and then we will run again. Now you can see the result has been improved, but it hasn't been improved much. So let's run again. Let's make the neural network a bit complex, and let's get another input into it. And you can see that the data has been converge. All of the blue dots and the orange dots have been separated. Let's move on to a complex data set to understand why do we need more hidden layers. Let's run it. So this data set is basically very difficult to converge, so we will need an extra hidden layer to converge the data. So what are the, so if we hover on to these neurons, it basically shows what a single neuron is doing. So the area that is blue is basically the area that will be separated as one binary class, and the area that is white will be separated as another binary class. So this basically represent where these neurons actually work to classify the data. So we will run it. The pattern is very complex. Let's increase the number of neurons to see whether our, so it is trying and trying to create a convergence line, and yet it is trying, but I think the computational power is still not enough, so we will need to get some more juice into it. So you can see that it has tried to converge between orange and blue lines, but as our neural network is too simple for this project, so we will need some more juice into it. Let's add some more juice into it. Let's get one more neuron here, and let's get one more neuron over here. Now let's run it again, and now let's see the data. So it has slowly started to actually transform our data, and let's see. The convergence line has started to appear. But I think this won't be enough. So for that we will have to add another hidden layer. Now let's run it. So let's actually increase the number of properties that we want to feed in as an input. So let's connect this, only that, check the behavior. Let's see how so it has slowly started to actually create a boundary between our two data classes. Let's add some more hidden layers into it. Now let's run it. Basically, I think the problem is that the properties that we are giving for the neural network to identify the both classes are pretty less. So it is basically has started to form a shape of the data. So we will have to increase the number of properties that we feed in. Now let's see. Let's add another hidden layer. Let's increase the number of neurons to get this data. I think we have made our model underfitted, so we will need to reduce the number of hidden layers. Let's do it again. So as you can see here, the problem is a bit complex, but it has started identifying the different parts as correct or incorrect, and most of the parts that it identified were correct, but still it hasn't separated the data clearly between two classes, but it has been able to show the orange areas and the blue areas separately. So we will say that if we will start to make the model complex, if we will increase the hidden layer and we will insert more features, hopefully uh, this uh, pattern will be identified by the neural network. So this is how you can actually identify complex. So this was basically actually just to give you guys an idea of how neural networks work. They get inputs at nodes and then they have hidden layers. The more the hidden layers are, the complex the neuron is, and then ratio of training to test data, noise, batch size, regularization, activation, learning rate, epoch. So these are the hyperparameters that we need to set in order for our neuron to behave, and then we actually provide the epochs. So that was it. So I've added 7 neurons in the first layer, 6 neurons in the second layer, 4 neurons in the third layer, and I've run the data, and now you will see that as the epochs increase, the data will start converging and it will separate uh, the yellow points from the blue points. See that after 1250 epochs, the data has actually started recognizing the blue and orange dots, and but still a lot of the orange part is being recognized as blue. So we will run it till 3000 epochs. So after running it for 3700 epochs, finally our most of the data has been classified except some points like some curves you can see from here to here. This part hasn't been identified while the rest of the part has got identified as a blue or an orange. So if we increase our hidden layers and if we increase the number of neurons, this will hopefully create a clear decision boundary between the two binary classes. If we increase the hidden layers, it will definitely work.